Hello everyone. Today we will be solving the yesterday's Leetcode contest questions. So the first question is special array 1. So in this question it is given that an array is considered special if every pair of its adjacent element contain two number with a different parity. So the question says that if an array is considered special if two adjacent elements are different in a parity like the if the first element is even number, then second element should be the odd number. Then since second element is odd number, then third element should be the even number. So this is our question. So you are given array of integer nums. We have to return true if nums is special array, otherwise we have to return false. So in this question we will check for every adjacent element that if their parities are different or not. If they have the same parity, then we will return false. Otherwise, we will return true. So this is very simple lead code easy question. So let's see. So in constraint, we have given that num length is 1 to 100. So if num dot length equal to 1 means there are only one element like in this example. In this example, if there are only one element, then we will return true because there are one element, so there are only one pattern means either it will be even or it will be odd, so we will return true. Otherwise for int I equal to 1, we will start from the second element. We will compare it modulo means it is even or not, means it modulo 2 equal to its previous element modulo 2. If it is equal means they have the same parity, means they are even number or they are odd number, both adjacent element are the same parity, then we will return false. Otherwise we will return true. So this is the solution. Like for this example, it will start from 1. 1 is an odd number and 2 is even number, so it has different parity. Then 4 and 1, 4 is a even number, 1 is a odd number, it has different parity, so we will return true. In this example 4 and 3, 4 3, 4 is even number, 3 is odd number, so we will return true in this case. For next 3 and 1, 3 is odd number, 1 is also odd number, so means there are not special array, they have the same parity, so we will return false in this case. So this is our solution. Submit it. So now second question is its follow-up question. So the question state same that array is considered special if every pair of its adjacent element contains two number with the different parity. So question title is same array special array 2. Special array has the same property means is two different adjacent element contain two number with a different parity. But there is a twist. It says you are given an array of integer nums of 2D integer matrix query where query I equal to from I to I. Your task is to check that subarray nums from I to I in special or not. So in the previous case, like in special subarray problems, we have to check whole into the whole array that it is special or not. But in this problem we have given queries, so we have given certain intervals, means we have to check that in this particular interval the array is special or not. So we have given the nums and the queries and we have to return the boolean array, means for every query we have to return that in this interval the array is special or not. Like for this interval, query is given 0 to 4 means from index 0 to index 4. Since here you can see 2 and 6 are index 0 comma 4 and have the same parity, so we will return false. For this particular question 0 comma 2 in the index 0 to 2, here you can see 3 and 1 have the same parity, so we will add false. And for index 2 to 3 means for index 1 or 6 means for subarray 1 6 there have a different parity, so we will return true in it. So we will add true and then we will return our boolean answer. So how we will solve this problem? So let's see. So first we get the number of elements, means num dot length. Then we create a unspecial. We create a array named unspecial of the same size of the num length. Then what we are gonna do? We are first one by one iterate in this array for every, means for every element we will add that how many cases occurs where the parity of two adjacent element have the same, means for 3 there are no previous parity checks, so we will return 0. For 4 and 3 are different, so we in this case we will add the fourth position value to 0. For 1 is before 1 there are no such case occurs where the two adjacent element have the same parity. So we will add a special at index to 0. For 2, the value will be 0 again. For 6, for 6, so for 6, you can check that for 2 and 6 have the same parity. So count will increase and value will be 1. So how are we doing? So we create a variable array of the same size and we are trying to get the number of conflicts like 3 and 4 we will check no conflict, 1 and 4 no conflict, 1 2 no conflict, 2 6 there is a conflict. So if num of I modulo 2 equal to num of I minus 1 modulo 2 means they are having the same parity, then we will increase the count value by 1 and then after that we will add unspecial I, means there are the array we have named unspecial whose I index means I equal to 1 to n. For value 0 and for value n, there will be no changes. Means for value 0, there are always count is 0 because there are no need element. Then if unspecial I equal to, then we store the number of queries into m and create our answer boolean m. Then we create a variable k equal to 0 for every query, means for every query what we are gonna do, we will find how many mistakes, means how many conflicts previously occurs in the certain index. So what we will do, we will find the, means from this unspecial array, means conflict array, we will find the every index value, means what is the conflict at the second index, means before 2 how many conflicts are there and before 0 how many conflicts are there. So we will get subtraction, means how many conflicts are in this range. So if there are no conflict in this range, so we will add answer k equal to true and we will increase value k plus plus. Initially all the values are false, so we do not need to add false because it is false already. We are increasing counter k so that if a value is true added, then k plus plus. If it is not added, then also k plus plus, means another element is false. So this is our solution. If we run it, then beats 100% user. So here you can check the complexity of big O of n, means what is maximum between big O of n and big O of m. So complexity is big O of n. So this is our solution. Thank you.